Hi, today me and my fellow classmates will be demonstrating how scientists break glass and different methods they use to break glass. First, my fellow classmate Tyrique will be showing you demonstrating how this submersion method works and talking about it. Then my classmate Kyle will be showing you radial and concentric patterns in large pieces of glass when it's broken. And I will be showing you fracture patterns in small pieces of glass. Hope you enjoy.
Morning class, my name is Tyrique. Today I'm going to do my part, which is the submersion method. So first I'm supposed to explain the definition, then I'm going to demonstrate it to you all. Let's get started. So first of all, the submersion method involves placing a glass fragment into different liquids known as refractive indexes. If a piece of glass and a liquid have the same refractive index, the glass fragment, right, will blend into the liquid. Like when you drop it in, it can just disappear, but it's still in there. So that's my explanation on what the submersion method means. Now to the demonstrating part. So what I have here, this is peroxide. Peroxide. The one mash it. This is water. These all look the same, I know, but they might have a different outcome when the glass fragment hits. And this one is too good. This one is rubbing alcohol, green one, not no alcohol we drink, green rubbing alcohol. Yes. So I'm going to show you all. This is the liquids I'm using. Put them back in their designated areas. Then we'll go in order. From right to left in a line. So first the peroxide. Let's see. Oh yeah, by the way, I have some glass fragments here right next to me. Left-handed. These are some of the glasses I have. I'm gonna put this glass fragment into this. I mean, you can still see it. I mean, it'll blend because it's clear, same as peroxide, clear, you know. I mean, yeah, cool, everything. I thought it would have been floating up or something, but you know. Then, next is water. They might have the same outcome, you can see right now. Glass fragment, water. Let's see what will happen. Wow. Okay, so let me say something real quick here. These two look different. I don't know if it's because the glass bigger, but the one with the water, it seems to blend in more better than peroxide. Look, you can't hear nothing in this. I don't think it's the size, but maybe different materials or whatever, I don't know. But next is rubbing alcohol. Let's see what will happen next. Ready? Rocking. Yeah, you can see it. You're supposed to see it, but at the same time you're not. Oh, okay, yes. So this is the green alcohol with the glass fragment. So now let me see if we can line them up in order. The one with the water seems to be the best one out of the three. I mean, out of these two. So yeah. Then it would be the peroxide. And then this. So yes, that is my project. Thank you all for watching.
Hello, good evening. My name is Kyle Edwin, and I will be discussing glass fractures. Now, in this video, I'm going to be using window glass, but there are different types of glass, like tempered glass and laminated glass, but window glass for this time. Now, first, I have my hammer and a nail. And I have my sheet of glass right here. Now I'm going to take the nail, put it in the middle of the glass, and use the hammer to apply force to break the glass. And that's what happens with glass. When you apply enough force, the glass will eventually break because there's a limit to how much force it can take. And when it does crack, it forms something called fractures, particularly radial and concentric fractures. And that's what we're talking about today. And a question that was asked to me is, which one comes first, radial or concentric fractures? And I say radial fractures come first because take a look at this. I don't know if you could see it properly, but yes, this is my glass. It's cracked. I cracked it before I started the video. See, radial fractures are the long lines that extend outward. Concentric fractures are more like lines that connect from each of these long lines to form a circular pattern. And the reason I say that concentric fractures come second, the radial fractures come first, because if concentric fractures need to connect from radial fracture to radial fracture, then that means if the radial fractures aren't there in the first place, then the concentric fractures would have nothing to connect to, and then they couldn't exist. So that's my reason for saying that radial fractures come first, then concentric fractures. And I think that this information could be useful to forensic scientists to help solve in criminal cases, like in hit and runs, forced entries, burglaries. And a case such as this one I have right here of Danny Peterson. Danny Peterson, 21-year student of Iowa State who died on June 8, 2002. A vehicle veered off the pavement, fatally hitting him, and then drove away. Peterson went to the hospital. A detective recovered small glass fragments of a windshield and a headlight in a nearby culvert. Fragments were also on Peterson's clothes. The glass on the headlight matches that specific car. The car was also a 2000 to 2002 Mercury Cougar in a repair shop on the day of the accident. After 3 months, a woman called the police saying that her husband, Guido Vivar Rivera, was drunk and lied about someone breaking his glass with a rock. Even though the glass was repaired, there was fractures on the bumper, possibly caused by the accident. The detective questioned employees who said that it was unlikely that it was a rock who broke the glass. The detective and his team obtained a search warrant for the Pontiac Grand Am. They also found pieces of broken glass in the car from the crime scene. The glass was also matched with the fragments on Peterson's clothes too. In the end, Rivera was convicted of hit and run, and he was served time at the Hennepin County Adult Correctional Facility. And that's just one of the many cases that has been solved using glass fractures. This is just a summary. You can read the full case online. Just type in Danny Peterson. But yeah, this is a summary of the case. But I mean, that's how I think that glass fractures are important to forensic scientists. Radial. This one is labeled inside of window, outside of window. Now, they're not exactly identical, but you see, I tried to mirror them. I also labeled them by letters. Like this is D, this is A, this is C, this is B. Same thing, A, C, C, B, B, D, D. Okay, and I colored them so it'd be easier to differentiate because the lines are intersecting with each other, so it'd be easier to differentiate which line comes from which line goes to each fracture. And speaking of intersecting lines, these are points of intersection where the lines meet. This is what's going to help determine which one came first. Now, as you can see, I think the order is D came first, then C, then B, then lastly A. Same thing was over here. D is the first projectile I had then, and in the list that I just said, that's how it goes down. Now the proof I have for this is, if you look, D is extending outward. It's not trying to hit anybody. It keeps cracking till it runs out of energy. Then C now, which is here, actually hits C, which is here, it runs into D. Right here runs into D, 2 points. On 2 points it runs into D. Then B runs into C on 1 point. Then A runs into C on 2 points. Oh, there's another point there. B also runs into C on another point. Same thing over here. D extends outward until it runs out of energy. Then C runs into D on 2 points. Then B runs into C on 2 points. Then lastly, A runs into C on 1 point. And that is how I determine which one came first.
Hi, my name is Peter Elwa, and I'll be showing you demonstrating fracture patterns in a small piece of glass. So, like my fellow classmate Kyle was talking about radial and concentric patterns, and he showed up the case and stuff. Now I'll be basically doing the same thing, but I cracked more glass. So I'll be showing you how the other two glasses connect to the first crack, or if it doesn't. So I already cracked the glass because I didn't want to waste time trying to crack it during the video, because it was giving me a hard time, but I got it. So basically, this one right there was my first crack that I was able to do. It extended out here, and down there. My second crack was right here, and this one connected back to the first crack that I did, but it also extended two that's out right here, out right here and right here, which kind of are in a circular pattern, but not really, so I'll just say it's radial. Sorry, the glass is kind of cracking. The third crack that I had was right here, where the big chunk of glass is missing right here. So when I cracked this one, it was kind of harder because the glass was looking like it was everything going to break, so I had to be careful with this one. This one, it extended out here and it extended out here also. It came back here, but the glass right here kind of broke, so I can't really show you how it extended back to the first crack. But the first crack from this one like kind of touched this part where the third crack was. So basically, all this that I'm showing you just relates to like how in crime scenes, how forensic scientists would have to examine where it may be, like if somebody broke in or somebody shot glass, they can see where the impact of the bullet or the hammer came first. and then they can relate that with seeing where the other patterns of the fractures came from. Like here, you might be able to see that the first one was here because of how I punctured the first one, because you can see that these second ones are coming out easier than the first one, because the first one has a different type of impact, but it's more stable.